Hello all, welcome to the subject of the microcontroller. I am Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvati Bai, Gyanma Mujhe College of Engineering, Waguli, Pune. Today we are going to see the interfacing the keyboard to the our microcontroller. So in the previous lecture we have seen the theory part. In today's lecture we are going to writing a assembly language program for interfacing the keypad. I have told that the keypad, there are two types of the key. One is non-matrix and matrix keypad. We are going to interfacing matrix keyboard to microcontroller. I will introduce once again the introduction about the keypad, how it will work, that it will easy for you guys for understanding and writing the program. The keyboard is a human-oriented input peripheral and it is used to input data or program into the computer, and it consists of push buttons type of switches. When key is pressed, the microcontroller identifies the key depression and then performs the appropriate operations. See, in this figure, these are the keys. These are in the form of push buttons. So when the key is pressed is nothing but when the button is pushed. When the button is pushed, it will experience the depressions and perform some appropriate operations. The key switch mechanism, the aim of this mechanism is to generate and transmit the code each time a key is pressed. And the mechanism should send one and only proper code when the key is pressed. The input keyboard is comprised of a set of the labeled push button switches. Each switch makes electrical contact with the pressed. The nature of contact should be reliable when have a long life and feel right. In case of push button key, the metal contact bounces few times, hence the voltage across the switch fluctuate and generate spikes in the signal. Therefore, it is necessary debonds the mechanical switches. What is the debouncing of the mechanical switcher? There are two types of switches there, hardware debouncing and software debouncing. We have seen the program for this debouncing. So in our program, we are considering the hardware debouncing, software debouncing. What is the software debouncing? Is nothing but it is one of the technique of the microcontroller, which will wait for minimum 20 milliseconds before accepting key as an input. So after 20 milliseconds, the key is pressed, the key is accepted by the microcontroller. So this process is called as a software debouncing. So we are calling delay in our program for this debouncing to overcome this debouncing problem. So we are accepting the software key debouncing. So key interface, how to interface the circuit, this keypad circuit to our microcontroller. We will see now. The keyboard is interfaced with the microcontroller through input ports. How we are going to interface? We are going to interface through input ports. These are the ports. We are going to interface the input ports. Through the input ports, we are going to interface our keypad and the keyboard, which consists of mechanical switches, and these switches are arranged in a non-matrix and matrix form. So this is the figure shows the non-matrix form, and this figure shows the matrix form. These two figures shows the matrix forms, and these are non-matrix forms. The non-matrix keyboard, the key closure is identified by reading the port data, but it requires many port line. the number of IO line is equal to the number of keys here. If we are using many number of keys here, is nothing but the number of IO line is required. For example, here only 7 keys or 8 keys are using. So we want to increase the number of mechanical switches or key, then we have to connect with these key with a particular input port. Other port we have to use here, but there is only 32 ports. So we cannot access all the port because all the pins of the microcontrollers are multifunction. So we need other key pins for other purpose also. So this is one of the disadvantages of this non-matrix keyboard. To identify the key value of the following, the functions should be there. First, we have to identify the, before going to connecting this keyboard to the microcontroller, we have to do some following functions or some performance. So first we have to check, identify key closure. Is any keys pressed or debouncing the key, and encoding the key to an appropriate code like a hexadecimal. So we have to think about that. Then above 3 functions can be performed through the hardware and as well as software. So how we can check the identification of key closure? We have to check by using externally one NAND gate can be connected to all these particular line where the registers have connected. So at particular line we have to connect one NAND gate. If when the output of NAND gate is low, that means the key is pressed. Otherwise, the output of NAND gate is high, then the key is not pressed. So we can see like this also. Now see matrix keyboard interface. So in matrix keyboard interface, the input line is required to interface one key, and this increase the number of keys when a large number of keys are to be interfaced. And this technique is not useful, but matrix method is used in such case so that the number of connections are reduced here. Here this figure shows so what will happen in non-matrix interfacing method. In this method, what will happen? The keys are organized in a matrix form. So there are in the figure shows this non-matrix method here. What will happen here? We can interface 16 keys with the 8 pins, 16 keys with the 8 pins as in row and column. See here, 4 pins are 4 row in the 4 rows and 4 columns. In between these matrix form, there are 16 keys are organized and connected like this. Hence, this method is very beneficial than that non-matrix interfacing method. So when there was no connection between each rows and column, if the keys are open, if any key is pressed, then what will happen? There is a connection will be established in between the rows, particular rows and column. If any key is pressed, the connection will be established at the particular row and column. Then the supply will be flow. So such matrix is requires only 8 lines to complete the connection. So this is the non-matrix keypad interfacing method. So in this non-matrix, all the columns are referred as the scan lines and the rows will be referred as the return lines. So when key is pressed, the corresponding row and columns are connected and they are shorted. If the output line of the row is high, it's nothing but then it makes a line column high and vice versa. So what will happen here? When the output of the any particular row will be high, then what will happen? The particular column line will be high, then vice versa. So key is recognized by the data and which is sent on the output port, and input code that is received from the input port. The steps required to identify key pressed is, first we have to identify any keys pressed or not. So while writing in the program, the first loop we write, first we have to start a program for this one. We have to first identify in all the keys open or not. So all the column lines are made 0, and by the sending low on the all the output lines, and all the keys of the matrix are activated or not, we have to check like this. So read the status of the row and return lines. If the status of all the lines is a logic high, then the key is not pressed. Otherwise, if the status of the all the line will be logic low. So in the second stage, we have to check debouncing the key using software debouncing. And next we have to identify the key is pressed or not. So in third loop, we are going to writing if in the program, if any key is pressed or not. In this, we have to activate the key from one column by the making the other column line or 0, or we can do like that, making one rows is 0 and making other row is all the rows are high. Like that we can check the identification of the key and read the status of the return line. What are the status? After we have to read the status, and then 0 on any return line indicate that key is pressed. So activate the key from next column and repeat these steps for all the columns or all the rows to identify any key is pressed or not. So let's see how to write a assembly language program for this 4x4 matrix keyboard, which is connected to port of the 8051 microcontroller. Here, what will happen? Two ports are connected. Here, all the columns is connected to the port 1 and all the rows are connected to the port 0. Here 4x4 matrix connected in between port 0 and port 1. So port only 4 lines are used of the port 1, that is from port 1.0 to port 1.3, which are used to scan the lines. Here the port 4 lines are using for scanning purpose, and port 0.0 to port 0.3, which is used for return lines. So these are using for scanning lines, and these rows are using for the return lines. So as I told, then we have to first check if all the keys, any keys are pressed or not, or we have to check all the keys should be open. So we have to check first while writing the program. So we will consider, before going that, we have to do one task, that is we have to move into port 1 the data that is 0000. FF. We have to load our port 1 to make a port 1 as input port. So first of all, we have to make input port. We have to make that input port. Then after that, what we are doing, first we are making these, all the lines are high. So for making all the lines are high, we have to load FFH. But we are using only 4 lines, but we are loading the data 0 FFH here. Then move P0, comma, hash 00H. to make ground all rows. So we have to making all the rows 0 for connecting purpose. First see here what we are doing here. See, there are a total, how many ports there are? Total 8 pins at this port 1. So we are doing all the pins are high by loading this data. So this 1 is nothing but F and this is F. So we are loading this FFH to make all the pins are high. All the pins are high is nothing but these are the input ports. So why we are writing 0 is nothing but we have to confirm that there should not generate any carry here. We don't want to generate any carry here. So that's why we have mentioned here. What we have mentioned here? 0 FFH. Okay. So to make these are, so first of all, we are making these are 0. All high and all 0. By loading 00H to this port 1. So next, let's see what will happen here. Move A, comma, P1. Why? Because we want to first read all columns. We want to read all the columns. What we are doing here? Here we are reading all the columns. We are checking all the columns are high or not. So moving this data into our accumulator. Then what we'll do, we will perform ANL A comma hash 0001111 B. Here what we'll do, we will perform mask operation. Mask operation, by executing this instruction, the ANL means it which perform AND operation between the immediate data and the data present in the accumulator. So in between these two data, it will make AND operation and the result will be stored in A only. So why we are doing these mask operations? See here, we are interested in only these 4 pins of the port 1. So remaining pins we are going to making 0 here. So for example, see, we have load P1 into A. So what is inside the P1? There, this much is inside the P1. This is inside the P1. So now we are performing AND operation with this data and this data. So this data 1 1 1 1. So we are going to perform AND operation between these two data. So what is AND? 1 1 1 1 1 high 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 high. It will provide remaining all the bits are 0. So I want to keep this data in our accumulator because I am interested only the 4 ports. What and the remaining ports should be I want to keep 0. So that's why we are doing here mask operation. Here we are doing masking. Mask unused pins, or we can say unused bit. So after that, what I am doing here, I am comparing and jumping if not equal to our accumulator data to this data. Where I am going to jump to loop 1 again. So see, in this loop 1, we are going to see if any key are pressed or all the keys should be open or not. We are going to checking here. See here, I am loading. First, we have to make all the keys open before going to start any operation. If there is any keys pressed, then we are taking as an input after the certain, and after immediately any key pressed is nothing but wrong code is generating that, which means that wrong information we are going to process and output is also wrong. So before going to put any data, we have before going to give any code to our microcontroller. So we have to check after connection all the keys should be in open state. So for making open state, we are making that here all the ports should be high and all the ports should be low here. And then I am moving this data into here. Then it will check by AND operation. If any key is pressed, then what will happen here? The other data will be present here. There is a not 0 0 other here it will become 0. If any is key pressed, then short circuit will be happen. This 0 1 will become to 0, and here after performing AND operation, this is not present that. So that's why I am making all the rows are high and comparing with this A value, and I am checking that I am telling that if these two are same, then it will try to execute the next instruction. If not same, it will jump to this L1. It will jump to where? It will jump L1 to proceed the same procedure here. Okay. So now this A is equal to this. There is no any jump will be there. It will start continuing the next of execution. So here up to here we ensure that no any key is pressed. So now we have to perform here in the loop 2. We will do the operation debouncing. Wait for certain time and check the key is pressed or not. Wait for certain time, check key is pressed or not. So after some time, I will call a delay. After all the keys are in open state, I will call some delay. Call delay. Here, this is the software debouncing. Here we are using delay. So I am calling delay for what? 20 millisecond. 20 millisecond delay. We are waiting for 20 milliseconds. After that, we are checking if any key is pressed or not. We are waiting for key pressing. We will checking same procedure we have did in loop 1. So I am loading A into our P1, A into our P1. If any is key pressed, the data is not high on this port. This data will be changed. So those data I am loading into our P1 into accumulator. Then I am performing A and L operation. A, comma, hash with 000 111. It will which will perform the AND operation and compare jump not equal our A to this immediate value. So here, if any data is pressed, what will happen? This data will be changed and it will loading into our accumulator. Then I am checking here if any these two are after performing AND operation. After performing AND operation, this result will become. I am doing AND operation here, AND operation masking. If this result will become, I will going to check here if this result will become, and this and this are same here. This result and this one is same. It means that no key is pressed. If both are different, is nothing but key is pressed, then it have to jump to loop 3. That key is not pressed. Both are same. If key, that means key is pressed. So keep if both are not same, if both are not same, key is pressed, then it have to jump to, if both are not equal, then it have to jump to loop 3. Loop 3. If both are equal, is nothing but no key is pressed. So it will S jump to loop 2. Again loop 2. It will jump to loop 2 and it wait for certain time until the key should be pressed, and it will check the same procedure, the key is pressed or not. Here, this is the loop 3. If key is detected, if any key is short circuit detected, then it will jump to loop 3. So what will happen in a loop 3? We will see same call function. We will call delay here. After calling the delay, I will check, ensure key pressing. Here again, move a comma P1 by using the same procedure. Move a comma same binary data. Move come here, perform AND operation. We have to perform AND operation. A and B. If any key is pressed, P1 data will be going to change there. There is no 00 will be remain. So it will load into the accumulator. Here we are going AND operation. This data, in this data and this data, we are going AND operation, and we are comparing the result. If both the result are not equal, then what will happen? If both the data is not equal to this result, the result is same, it means there is no key is pressed. If both the data is not equal, that means key is pressed. If key is pressed, we are going to loop for. If not key pressed, so S jump. Not equal, both are equal, that means key is pressed there. So S jump JMP. This is short form jump. So S jump to loop 2 here. Here we are checking, ensuring here the key press or not. We are getting the key press here. Here we are ensuring if after if both the result are same, it means no key is pressed. Then it will go for loop 2 again and follow the same instruction. And if both are not same, it means key is pressed. It will go for loop 4. So what is the operation of loop 4? So any key is pressed in the loop 4, it will come into the loop 4. In the loop 4, we will scanning the particular line by making the high of the all the rows. By making high all rows, and at particular row we are making 0 here. All are high. Then we are going to scan at particular line here. I want to scan at particular line and try to take if I try to take information that if any key is pressed or not at that particular row. So identifying any key is pressed on that particular row. So I want to make that row only 0 or low. I want to put that low signal on that particular row. How? By writing this instruction, I am loading port 0. What data I am going to load here? I am loading 444. This data I am loading into the port 0 is nothing but what will happen except the row 0. Except the row 0, all the pins of this port 0 will be high except the row 0. I am going to check whether any key is pressed or not at that particular row. So writing this instruction, then what will do after I will load that information into accumulator. no, I am loading. So I am loading port 0 at this, and I am loading what are the status of this port 1 and loading into the accumulator. Then I am performing ANL operation with respect A, comma, hash 0000 1111 B. So up to loop 3, we have up to loop 4, up to loop 3 completion, we have detected some keys pressed. Now we are checking at what particular row the key is pressed. So we are going to scanning one by one particular row. So we are starting from the row 0. In what will happen here, row 0, we are making 0. So how we can make only row 0 is a row 0. So we are loading the our port 0 with this immediate value. What will happen after loading this immediate value, this port 0? All the port pins will become high except the port 0. The port 0 remains low only. Then what we are loading here, the respectively the same information will be changed here. So respectively, I am loading this port 1 data into our accumulator. Now I am checking the ANL. I am checking the both performing a AND operation, and after performing AND operation, I am checking the result with this immediate data. So after, if both the data are same, is nothing but there is no any key pressed. If definitely there will be a change will be occur, because if any key is pressed, then only this loop will be execution of this loop will be start. So these two are not changed. It's nothing but some key is pressed at this particular row. Then what will happen? So it will go to row underscore 0, this label. It will go to this label. If both are same, is nothing but there is no key pressed at particular row. So it will try to check the next row. How it will try to check the next row? Here. So instead of making this bit is low, now the row 2 should be make 0 here. So what we are doing here, so our before we did it, this row will made, before we have made this row is 0. Now we have not getting any, we have not detecting any key pressed in this row. Then what we should do, we will go for this row. Except this row, all the pins of this port 0 will be high except this row. So how? By loading this value, by loading this value to the port 0, what will happen? All the port pins will become high except this port P0.1. So then respectively the same, I am loading this data into our accumulator and performing AND operation. And after AND operation, the result will be stored in accumulator. Then what we'll do, I am comparing that result with this immediate data. If both the data are same, it's nothing but there is no any key press at that particular row. If both the data are not same, is nothing but it will jump, it will compare. If both are not equal, then it will jump to row 1 now. If both are not equal, it means some key is pressed at that particular row, then it will try to execute the instruction at this label, row 1. So what will happen in this particular label, we will see after that. For time being, you have to remember that if these two are not equal, that means some key is pressed instead that this particular row, it will jump to this particular label. If both are equal, it means that no any key pressed at this particular row. So it will try to scan the further. It will try to scan further. So here we have seen the row 1. Now what we are doing here, we are now we are doing row. This row is high. Port 0.2 is high. By making this bit is 0, all the pins of the port will become high except this row. Now we are going to scanning this row if any key is pressed in this row or not. Then simultaneously we will load the port 1 value into accumulator and we will perform the AND operation with this data. If result will be stored in a and we are going to checking the both the result are same or not. If both the result are same, is nothing but there is no key pressed at this particular row. If not same, it is nothing but the some key is pressed at this particular row. So it will jump at time this label. Otherwise, it will perform same operation here. Now it will check. No, this data will be loaded into port 0 and make this row will be 0 here and perform the same operation. If both the data is not equal, then it will jump to row 3. It means some key is pressed. If no key is pressed still, then also we have not detecting any key, then it will simply long jump will be take place here. L jump to where? L2. So if any key is not detecting, so one of the key should be pressed at this particular row. If row 0 not getting any key pressed, then it will check to row 1. If not pressed, row 3. If row 2 and row 3. Till then also, if no any key press detected, then it will see it will directly jump to this loop and it will perform the same operation starting from this loop. So if any, we are going to think some key is pressed, so it will jump to row, this row. So what will happen in this row, we will see here. So in this label, what will going to happen there? So at this label, row underscore 0, what will happen there? There will happen move dptr hash equals 0. I will write all the code, then I will explain here. This is for row 1. Then what will happen here? This code row 2. If you guys want to understand the concept, then it will very easy for writing the code. If these two data is not same, then it will jump to row 0. Row 0 is nothing but here, it will come here. It's nothing but some keys present that particular row. If any key pressed is this particular row, it will come here. What we'll do here, loading our data pointer with this key code 0. What is this key code 0? This is the address of that lookup table where the data is present. So here's lookup table. I will show the lookup table, how the data will be present there. So this is lookup table. In that table, we have stored at that particular value key code 0, which is having address starting from the address DB. This is the address. And at that particular row, what data will be stored? This data will be stored. Hmm? See here, after what will happen in this row underscore 0 label, it will move this code into the DPTR. What is this? This is the address of this lookup table. So this is the information stored in the lookup table. The address of this lookup table starts from this org 300H. So this is the address of this lookup table at the key code. Sorry, this is not B. This is the key code. So at this key code 0, this data is stored. So according to key, what key is pressed at that particular row, that data will be going to access. So after accessing, it will jump to directly jump to find. Find is the another loop there. So what is inside, what will happen inside the find, we will see later. First, for time being, you have to remember the address of this will be stored into DPTR to access this data. After accessing, it will load into the sjump find. So similarly, what will happen if these two are not same? It means that the row 1, there is some key pressed at this particular row 1. So then it will directly jump to here. Then they load this value into this DPTR. So what is inside this one key code 1? This data is stored. So this data is stored. So what is the at the particular key location, that data will be accessed and find to sjump to find. So what is find, we will see later. Similarly, if these two is not same, that means some key is pressed at this particular row 2, then it will come here. Then this key code 2 will be loaded into DPTR. So this is the 2. So key code 2, inside the key code 2, it will check the lookup table and this data will be stored. So it will try to access this one. If these two are data they present in between accumulator and this immediate data is not same, is nothing but some key is pressed at this particular row, load this code into this DPTR. Then what is inside this DPTR? So this is key code 3. This lookup table contains this data and it will access and jump to find. So now see what is the operation of find. We will see here. I will write here what is the find operation is here. The find loop having which will perform RRCA. So this RRCA is nothing but it will check any carry is generated or not. Then JNC DPTR What? What? What will happen in the find? We will see here. This find loop will become here. In this find, what will happen? It will find the key belongs. It will find if any carry bit is there or not. So this RRC is nothing but if any carry bit is there or not. Then again it will if the carry bit is 0, if the carry bit is 0 is nothing but it will get an ASCII code. It will get a ASCII code. Then it will point increment the DPTR and yes jump to find. If any carry bit is 0, there is or not. If carry bit is 0, then it will jump to this label. If there is a carry bit is there, then what will happen? It will increment and S jump to find again. So what will happen in this loop? It will clear accumulator and move C at A plus DPTR. So here what will happen? What is the data inside the DPTR? It will load into move. It will move into accumulator. Then that data will be moved to port 2 because the output we are reading from the port 2 and what are the data present at this accumulator plus DPTR both are added and that data will be loaded into the accumulator, and this accumulator will be loaded into port 2 for reading the particular data. Then after it will jump to L1, long jump. So after that it will jump to L1 and start doing same process. So this is the assembly language program for interfacing 4x4 keypad to the 8051 microcontroller. In the next lecture, we will go to see how the 7-segment display will be interfaced to the 8051 and how we have to write the program. We will see in the next lecture. So this is enough for the day. Thank you.